one or another way, we are all suffered from this influenza virus, and we are keep on suffering because this influenza is commonly known as the flu. It's an infectious disease caused by influenza virus. So this virus causes the flu. Flu is a common thing, particularly for Indians. It is a common thing. It's a seasonal thing. Symptoms are, if you look at, there's a range mild from fever, runny nose, sore throat, muscle pain, headache, and coughing, fatigue. All those things are together. We call the influenza symptoms, and these symptoms begins within one day, and then it lasts for maybe a week. Then we will get. But in some cases, it may go to a high end, like vomiting and other problems, or sometimes people may develop a pneumonia and some acute respiratory illness problems and meningitis, encephalitis, cardiac problems. So many things are associated with this influenza virus, of which variety, whether it is affecting avian flu, whether it is a swine flu, whether it's a normal influenza virus, so whether it's a seasonal flu. So many issues are there. Some are under severe threat, now they are become a seasonal flu. So in these aspects, we are going to discuss mainly about influenza virus disease, and specifically about H5N1 and H1N1, the specific subtypes of this influenza virus. And we are going to give a kind of a comprehensive analysis. So we'll look at some basic aspects of influenza virus. Influenza, commonly known as the flu, is a highly contagious respiratory infection caused by influenza virus. So we all know, we are all suffered and still suffering, and we are going to suffer also. And influenza virus belong to the Orthomyxoviridae family and are classified like influenza A, influenza B, and influenza C. Type A influenza virus are further categorized based on the surface glycoprotein. That's why we have a hemagglutinin HA and neuraminidase NA. So that is H1N1 we call. No? So based on this, and these viruses have the ability to undergo antigenic change and leading to seasonal epidemics and occasional pandemics. So this is the challenging, because they keep on changing their genetic material. As they change its genetic material, it changes the antigenic property, and sometimes it may be epidemic problem, sometimes it is occasional pandemic problem. Sometimes one in a class, if they got infected, whole class will get infected. So it's a challenging thing. But sometimes it go beyond our hands and it will become a pandemic. That's what happened in 2009 and all, avian flu, sorry, swine flu. So then what is the virology of this influenza? So influenza virus is enveloped RNA virus with a segmented genome, and genetic diversity of influenza A virus is results of antigenic drift and shift. As we all know, antigenic drift and shift is highly responsible for variety, creating a new varieties, new strains out of the existing strains, and which occurs through a point mutation and assortment respectively. These mechanisms contribute to the virus ability to evade host immunity and cause periodic outbreaks with varying severity. So the severity of a disease, one thing is our body will develop immunity. Next time same virus attack with a different strain. Virus is same, genetically they are almost same, but there is a slight variations because of drift and all. So what happens? It attacks us and it will be a new virus. So body start producing symptoms. Symptoms may be a basic symptom like pain, headache, the running nose, fever and all. Sometimes it move to a pneumonia, severe problems. I mean the cough pneumonia, I mean the accumulation of fluid in the lungs. All those issues are there associated with this, but it won't happen generally. Generally the symptoms will be mild, but in some patients, those who are immunologically compromised, or they never exposed to this kind of virus, or may they have not taken a flu shots. All those people may show high-end or varying severity of symptoms. Epidemiology, if you look at, we are looking at this from influenza point, then we will discuss about both subtypes, H5N1 and H1N1. So influenza is a global health concern, we all know, causing annual outbreaks that results in millions of infection, hospitalization, and deaths. So we till appearance of a new novel coronavirus, we were not much concerned about these influenza infections. But we know this is a simple problem, but it can turn to a complicated issues. Depends on age of a patient, immunological compromise, if he has done or she has done. I mean the body showing, then the problem may be more to, so otherwise it's manageable. The virus spreads through respiratory droplets. This is a challenge. That's why we were wearing a mask through which we can manage. Certain populations, such as elderly, young children, immunocompromised individuals, are at high risk of severe complications. Pandemics, which occur when a novel influenza virus subtypes emerges and pose a significant threat to public health. So this influenza is a challenging thing, and influenza causing a problems. We know about Spanish flu and all from there how the problem started, and it eradicated whole population. I mean the whole area population itself. So now we have evolved. We have a medications, we have a flu shots, so we can manage disease, and we can give them a supportive care, proper supportive care. Earlier there was no research, there was no scientific development to this level, so they couldn't manage this. But today it's not like that. You can manage it well. Now, what is a clinical manifestation of this? So we all know the commonly it is having fever. Sudden fever comes, chills, cough, sore throat, muscle aches, fatigue. So this is the common problem. So in first day we don't feel any fatigue, but second day onwards we feel fatigue because see when influenza enters the body, it's intracellular pathogen. I mean the virus which start killing our cells and body start attacking them. So self-made damages are more here as we damage our body after infection after infection. So we show fatigues, and sometimes people feel nausea and vomiting. They don't eat much and the sugar level go down, and all those issues are there. Respiratory symptoms can range from mild to severe, and complications such as pneumonia, bronchitis, exacerbation of pre-existing condition may occur, particularly in vulnerable populations. So this is the challenge. Some hidden or maybe congenital problems, some hidden problems may be there, but those problems won't be a much symptom showing one. But what happens when this virus infects? So this starts showing symptoms. So that's a challenging one. When some other infection happens, this will start showing symptoms. Till that, it don't show any symptoms. Particularly, uh, people are diabetic, pre-diabetic. Maybe this infection turn them to diabetic. If they are borderline of blood pressure, I mean hypertension. But if because of this infection, psychological issues, stress, and all those things, medication, they may turn to hypertension. So these are all the challenging things. So first, then we will look at this influenza virus subtype. That is influenza virus H5N1. It's a subtype of influenza A virus which can cause illness in humans and many other species. And this bird is called as avian influenza, or else it's called bird flu. So influenza subtype H1N, commonly known as avian influenza or bird flu, has garnered a global attention due to its potential for causing severe disease in both birds and humans. I mean, today's world, half of them, maybe more than half. Now, because of veganism, it may not be true. But if you look at a whole global, so we are main non-veg food source. I mean, the food meat eaters, we are going to eat chicken. Chickens are reared only for eating purpose. So what happens? It is a huge industry. Millions of jobs associated with the billions of dollars invested there. And if anything go with wrong with that, that will we have to kill all those uh, animals, particularly birds. And from birds who are eating birds or working with the birds can transfer to humans also. So influenza A/H1 is highly pathogenic avian influenza virus that primarily infect birds. However, its ability to cross the species barrier and infect humans has raised significant concerns regarding public health and global pandemic potentials. So that means it's sometimes this virus can cause break these barriers, and it is highly pathogenic. That is, it's a zoonotic virus, and especially in Southeast Asia, particularly China and all, China, Southeast Asian countries. It's a challenging, and culling hundreds of birds is really a loss for a whole globe because as for the World Health Organization, and so because these birds are farmed birds, it's not a natural bird. I mean the birds which are there in the natural habitat, it's all farmed birds. So killing them leads to huge economic losses. And so 11 outbreaks of H5N1 were reported worldwide in June 2008 in 5 countries like China, Egypt, Indonesia, Pakistan, and Vietnam, compared to 65 outbreaks in 2006 and 55 outbreaks in 2007. The global HPAI, that the situation significantly improved in the first half of 2008. And if you look at the whole history, reported that World Health Organization reported that around 861 confirmed cases, which resulted in death of 4,455 people in 2003. That is the old history I'm telling. So then several H5N1 vaccines have developed and approved and stockpiles by a number of countries, and including the United States, Britain, France, and people started using it for the emergency purpose. Now, virology of H1. H5N1 is a top type of influenza virus characterized by a surface glycoprotein, hemagglutinin H, and neuraminidase N. It is classified as a highly pathogenic due to its ability to cause severe disease in poultry, and the virus undergoes a genetic resortment and leading to the emergence of novel strains with the pandemic potential. So that's virology of this. Transmission dynamics. How did it really get transmitted? H5N1 is primarily transmitted among the birds through a direct contact with respiratory and fecal secretions, because people work with these birds and people kill the birds, they use the blood, culling, all those issues, because people are in a constant touch with these birds. So when birds are having this virus or birds are infected with this virus, surely it can easily transfer to the people who are working with that. And human infections often results in close contact with the infected birds or contaminated environments. While sustained human-to-human transmission is rare, the virus has the potential to acquire genetic changes that could enhance its ability to spread among humans. So this is the challenging thing. See, it may enter into few human people, I mean the population. So particularly maybe in Egypt, it might have entered a small group of people. It's very rare that human-to-human transmission will happen in such a rate like what you see in case of birds. But this virus may go for genetic dictatorship, because of the mutations. This virus can easily change its antigenic potential and start moving from human to human. So this is the challenge. But we are speaking about transmission dynamics in that one. No? So this is the challenging one, because it shows a symptom similar, because all those symptoms are similar to our normal flu. But you look at yeah, this one in some of these infections, body in a way to kill these pathogens, the body produce a kind of a specific inflammatory response, particularly for H5N1. It's called cytokine storm. So because it's a positive feedback system where we can manage our system, but its attack is too much that the body whole system will collapse and people die. That's the challenge. And clinical signs of this H5N1 birds range from a mild decrease in egg productions, nozzle discharge, coughing, sneezing, all the similar symptoms even in birds, but almost similar symptoms in human beings, because human don't lay egg, but still are remaining problems for protein like this. So because it's all of nozzle, I mean respiratory illness. Clinical manifestations you can see. In humans, H5N1 infection can lead to severe respiratory illness, acute respiratory distress, ARDS, where in some cases of death also. The clinical course is often characterized by high fever, cough, respiratory distress, pneumonia. Just because small dots start appearing in lungs. I mean the viral pneumonial infection. I'm not talking about a bacterial pneumonial problems, but viral pneumonial problems. This is a challenging. And mortality rates among reported cases have been alarmingly high for severity of H5N1. So those who got this infection, no, death rate was really high. So that is a challenging one. Death rate was really high. Around 800 reports, around 455 people are died. So that's a challenge. But in other flu, it's not like that. Prevention and control is quite common for H5N1 and H1N1. And look at it similar to common cold. The preventing the spread of H5N1 involves the multifaceted approach, control measure in poultry, including culling infected bird, strict biosecurity measures, and vaccinations. So this is all challenging in third world countries. How well you can implement this? The World Health Organization, CDC, or maybe NIH may tell people to do this, but how many of them will fall? Because people are so much concerned about their birds, particularly millions of dollars are invested there, and culling infected bird is also a challenging one. In human, early detection, antiviral treatment, some of the antiviral and strict infection control measures are crucial. Developing and stockpiling H5N1 specific vaccine is a key component of pandemic preparedness. So that means now one thing is we need to develop a strategy, we need to develop enough vaccines and we keep it in our warehouse. Whenever emergency comes, we can use it. So prevention and control. So I mean the human to human transmission through maybe wearing a mask and all those things, but at the same time we can manage this disease with some of the available antiviral treatment also, like oseltamivir and all we can use. Challenges in containment. The controlling H5N1 presents several challenges, including difficulty of implementing effective surveillance in poultry populations. How well we can implement this surveillance system? Who will follow it? So that's a challenging thing. And the potential for asymptomatic birds carrier. Some birds may show no symptoms, so that may act as a carrier. And the constant trust of genetic resortments, the genetic recombinations or genetic changes. So creating a more transmissible strains, more potent strains, more virulent strains. And global cooperation and information sharing are essential to address the challenge of preventing and controlling H5N1 outbreaks. So that means a global cooperation we need. It's not simply one person sit and do something. It's not sufficient. Global cooperation we need to work with hands. So next we'll look at another influenza virus variety of subtype A, that is influenza virus H1N1, unraveling the pandemic of 2009 and beyond, because 2009 that was the pandemic year of this. The H1N1 is sometimes called a swine flu. Swine flu means you are a pig. And during 2009 to 10, the flu season, a new H1 virus began causing illness in humans. It was often called a swine flu and was a new combination of influenza virus that infects pigs, birds, and humans. It's a combo. The World Health Organization declared the H1N1 flu to be pandemic in 2009, and that year the virus caused an estimated 28 lakhs death. Approximately 28 lakhs people are died because of this. In August 2010, the World Health declared the pandemic over, but the H1N1 flu strain from the pandemic becomes one of the strain that causes seasonal flu. See, what happens is 1 year, many people are died, many people are infected, and many people are died. But the problem is this will, in some pocket, it survived this virus and changed its genetic constituents, and it has become a seasonal flu. Most people get better on their own, but it's not true in all the cases. Influenza virus subtype, this H1N1 particularly strain responsible for 2009 pandemic, we discussed about that, I told about that, has played a significant role in shaping global public health perspective. Because that also helped us to pile up something which is required to manage this kind of problem. So that helped us during COVID. Influenza A type H1N1 is a respiratory virus that circulates in both humans and animals. The H1N1 strain gained global attention in 2009 when a novel variant emerged, leading to the first influenza pandemic of the 21st century. That means this is the first pandemic. What we have seen in case of COVID was the second pandemic. But in first pandemic, we could manage it, and population was also not this much. See, just remember, it was 600 to 700 million. Now it's around 800 to 900 million. So the population, millions of people are increasing on the globe. And after 20 years, we can understand. Sorry, after 12 years, 12 to 13 years. Virology. What is the virology of H1? It's a characterized by surface like hemagglutinin neuraminidase, and the virus has ability to undergo genetic recruitment with pandemic potential. And 2000 H1 and pandemic strain was a result of combination of human, avian, and swine. Then emergence and epidemiology and clinical manifestations of this. The 2009 H1N1 pandemic originated in Mexico and quickly spread globally, and its unique genetic makeup coupled with a lack of pre-existing immunity in human population contributes to sustained transmissions. So we were not exposed to it. It's a new thing. So what happens? Everyone will get the infections. Many will die. Many will survive. Get the immunity. That's the strategy. The pandemic results in millions of infections, highlighted the challenges in predicting and controlling emerging influenza strains. H1N1 influenza typically present with symptoms similar to seasonal flu, including fever, cough, sore throat, body aches, then runny or stuffy nose, watery or red eyes, eye pain, body aches, headaches, tiredness, weakness, diarrhea, feeling sick to the stomach, vomiting. But this is more common in children than adults. Flu symptoms may develop after 1 to 4 days after exposed to the virus. In severe cases, could lead to pneumonia and acute respiratory distress (ARDS), and particularly in younger age groups. The pandemic strains disproportionately affected young adults and pregnant. So it affected in all category of folks, like women, pregnant women, child, young ones, infants, old ones, adult, everyone. So what was the vaccination strategy after after this pandemic? The vaccination played a crucial role in mitigating the impact of H1N1 pandemic. The global monovalent vaccine was developed and distributed globally. The experience emphasized the importance of rapid vaccine production's distribution during pandemics. H1N1 is now included in seasonal influenza vaccine, and uh, because this is what you call the flu shots. We have to take the flu shot so we can manage this. And when we talk about this vaccine and all, there are some risk factors associated with this. This I have to tell. One is age. Influenza tend to have worse outcomes in children under age of 2 and adults are above 60 and 65 and up. Then living or working conditions. People who live or work in facilities with many other residents are more likely to get the flu. And some is packed populations, particularly labor camps, people living together. So there is a possibility that people easily become sick. Some so nursing homes or military barracks, people who are staying in the hospital also are at higher risk. Then weakened immune system. This is the challenging thing. So this is all I need to discuss with you all. It's like weakened immune system, cancer treatment, anti-rejection medications, long-term use of steroids, organ transplants, blood cancer, HIV/AIDS. These are all the things which can weaken these people, and this can make it easier to catch the flu and may increase the risk of developing complications. Then chronic illness. Some people may be suffering from chronic illness. The chronic condition may increase the risk of influenza. Example, asthma, lung disorders, diabetes, heart disease, nervous system disease, then metabolic disorders, liver, blood pressure, and other problems, kidney problems. People, those who are chronic. Then race. American Indians or Alaska Native people may have a higher risk of influenza complications. Some race, it's like we say, no, heart-related issues are more in India. Similar like some Native Americans, some Mohicans, or maybe those Huala Pais, Huasa Pais, or maybe native people of Alaskans. They are more prone for this. Aspirin usage. People on long-term aspirin therapy who are younger than 18 years of age at risk of rare syndrome if infected with influenza. Pregnancy, people those who are pregnant, they're high prone. Obesity, people with higher BMI. So this is another challenging things. Public health response and preparedness. How we were prepared for to tackle both H5N1 and H1N1. So here we have to take some precautions. That means wash our hands with 20 seconds with soap or water, alcohol-based disinfectants. Cover when you cough, sneeze, or something like that. Avoid touching your face, like eyes, nose, and mouth, which is a reservoir of virus. Then clean and disinfect surfaces. Which avoid contact with the virus. How much possible, that much you avoid contact with the virus, so you can manage the disease well. So if a particular person is, it's like a strategy is like that. Identify the patients or people who are showing symptoms, isolate them, give them a supportive care if they really require a treatment. Otherwise, allow them to cure themselves. So it's something like what we are doing is we are allowing our body to manage this disease by themselves. So give some times, rest, of enough fluid intake. These are all the possibilities. Now, whether public health response and preparedness is another challenge, because whenever a pandemic comes, this developed mammoth economy we call, they can manage things better than us. But during COVID, you understood some of the mammoth economies were struggled because they don't know, because it's all unseen enemies. So it's an unseen foe. We have not seen our enemies. So then we're tackling them is difficult because we don't have any scientific data for that present enemy. Particularly happened in COVID. Same thing happened in 2009 H1N1 infection. I mean the pandemic. Millions of, I mean the lakhs of people have died. Given the potential of our H5N1 to cause global pandemic, international collaboration in surveillance, this is important. Research, data collections, and vaccine development is crucial, and timely sharing of data in international communities, resources, along with coordinated effort to improve global health infrastructure can enhance preparedness and response capabilities. It is something like some countries are well advanced in medical sector. So there are some countries which they could not. The primary healthcare center is not proper. They don't have some life-saving drug medications. They don't have facility to store the drugs. So if some countries can sponsor something good in those countries which are not developed, that means it's a preparedness. So global preparedness is different. The country's preparedness is different. So when you talk about a global preparedness, so a few countries in a globe, if they prepared for the disease, is not sufficient. Everyone should prepare themselves. Then only we can achieve the target. Next is H1N1 pandemic prompted a re-evaluation of a public health responses, strategies, and the importance of international collaborations. It underscored the need for effective communications, antiviral stockpiling, and the development of flexible vaccination strategy to address emerging influenza threats. So I think in that one, we should appreciate India, because India went for the vaccine diplomacy, and we gave vaccine to some of the poor neighboring countries. We shared vaccines, and it was not our technology. Even though we had a constraints, we were like borrowed a technology and produced them. We were just a production unit, but we could manage it. We produced it in large quantity, and that time the whole globe appreciated India. So this is the way how every country can play a role. No, so it's something like all the country cannot be good at everything. So some countries can be good in production of this one. Some countries can be good in production of mask and other maybe some other life-saving drugs, or they may be providing protective equipments, a particular PPE kit, personal protective equipment like PPE kits and all. So they can manage. So China has done that. The H1N1 pandemic prompted a reevaluation of public health response strategies and the importance of international collaboration. So it really helped us to make a stockpiling of whether so it's like we can procrastinate, things may go wrong in future like this, so we need to have this much stock of drugs, all those things. In conclusions, in both like so when you look at this one, before concluding, in 1918 to 1920, well, that was a Spanish flu pandemic, which started from there. Avian influenza and viral infection started from there. There, millions of people are died in Spain and other regions of Spain. Then slowly people got. Then 1976 swine flu attack. 1976, a novel swine flu caused a severe respiratory illness in 13 soldiers in Fort Dix, New Jersey. From there it has started. Then 1977 Russian flu. So 1907 Russian flu pandemic was caused by a strain influenza, H1N1 only, and it infected mostly children and young adults. That killed many people. Then 2009 pandemic. Recent one is 2009. Influenza virus subtype H5N1. If you are looking at H5N1, so was a significant threat to both animal and human health. Vigilant surveillances, that means a surveillance system, data management, rapid response to outbreaks, and investigation in research and vaccine development are essential for preventing and mitigating the impact of H5N1 infections. The lessons learned from dealing with H5N1 can inform strategies for addressing emerging influence threats and strengthening the global health security. So we need to collaborate each other. We need to join our hands with hand. The country, those who are good in medical development, I mean the skill, and good in developing strategies, research and all, they should do the research and they should share that knowledge with the country which they couldn't. Because when it's a global problem, all the countries should work together, because our target is to eliminate that unseen enemy from this world. An influenza virus H1N1, especially the 2009 pandemic strain, has a left lasting impact on global public health. The lessons learned from the pandemic, including the importance of surveillance, rapid vaccine development, international collaboration, continue to shape influenza preventions and preparedness efforts. So that means we could learn something from this all, like where is the flaws, loopholes, how we can manage to tackle these loopholes, all those things. Ongoing research and vigilance. So research should continue because this virus keep on evolving, no doubt. its shape because it's prone for the genetic material is small, it keep on changes its shape and so on. So we need to tackle this. We need to develop strategies after strategies to manage this. Otherwise, what happens? No, we will get lag behind. The virus will evolve more, so it will cause infection against to us. So that's why to avoid any future pandemic threats, we need to start working from today itself. Thank you.